It's a sad day. It's our last day of notes. Let's take a moment of silence. Alright, let's get started. Alright, let's try to find the following limit. Let's try substitution. If I plug 0 in, we're going to get the sine of 0, 0 over 0. Well, what's the sine of 0? 0 over 0. Again, we get our indeterminate form. Okay? So the problem is, we can't solve it by substitution. We also can't factor it. It's not irrational, so we don't want to graph this. So what do? This is a special rule that we're going to talk about. There are some special trig limits that we aren't going to learn how to do yet, but I'm just going to give you what their answers are. We need calculus to actually solve this one. So, there are 3 special trigonometric limits that we need to know. And we're going to learn more about these and other techniques in calculus. The first one is the limit as x, not z, I don't know where the z came from, as x approaches 0 of sine of x over x is equal to 1. Tangent always follows sine, and again that should be x's, not z, so obviously there's some typos on here. So the limit as tangent goes to 0 of tangent of x over x is also 1. And the third one is the limit as x goes to 0 for cosine of x minus 1. No, it's not just cosine of x, but cosine of x minus 1. And that's because cosine of x, or cosine of 0 is 0. Is 1. So we get 1 minus 1 is 0 over 0. And that's going to give us 0. And there's our rule. Very easy to do these once you know the properties. If I take a look at the first one, I have 3 times sine x over x. What you're looking for is this, the sine of x over x. And like the 3 is a constant, we can take that out like we did yesterday. We get 3 times the limit as x goes to 0 of sine x over x. Well, 3 is a constant, that stays. But remember, what does this all become here? My rule says it's just 1. So my answer is 3. We're approaching the number 3. Let's try number 2. Now it looks like our cosine one, but instead of cosine x minus 1, we got 2 cosine x minus 2. So obviously we can factor out a 2 here, and it is a constant, so we're going to pull out to the very beginning. So if we factor out the 2, that's going to leave us with the limit as x goes to 0 of cosine of x minus 1 over x. The 2 is a constant. Remember, we just learned this rule right here. That's just equal to 0. So this limit is approaching 0. Remember, I keep writing out the limit until I know what the value is equal to, or until I can substitute. Now, 3 is a little tricky, but it is just like number 1. There's a constant, but this time the constant's down here. So that actually becomes factoring it out, becomes a 1/4 times the limit as x goes to 0 of sine x over x. Remember, what you want is that sine of x over x. That's what we want. We get 1/4 times, and our rule says that's 1. So what's our answer? 1/4. These are very easy to do. Okay? And remember, we're not learning how we get these answers. We're just learning what to do with them, how we can use the algebra to simplify it. Alright, the hard one is number 4. And we're going to spend some time on a problem like number 4 here. It's not as simple as factoring out the 7 because that's not sine times 7x, that's the sine of 7x. So what I need to do is look at my rule. Notice right up here, sine of x over x. Okay, that's what I want. Here I have sine of 7x over x. If this x had a 7 on it, I'd be in the same pattern. We just want those to be the same. So what I'm going to do is I want this to be a 7x. So what do I have to do to make the bottom a 7x? Multiply it by 7. But there's a rule in algebra. If I multiply the bottom by 7, so I'm going to rewrite out the question. If I multiply the bottom by 7, I have to multiply the top by 7. And what we wind up with is the limit as x goes to 0 of sine of 7x over 7x. Now, that's where the 7x goes to. But what about this 7? Well, I'm going to treat that as like it's an extra. It's just an extra. I'm going to bring it to the front. So I get 7 times that. And what's the answer? Well, I keep the 7, it's a constant. The limit as x goes to 0, well, that's from earlier. It doesn't matter what the 7, it doesn't matter what this is. As long as these are the same, the answer is just 1. So what do we get? 7. So we have a rule. If we're taking the limit as sine of x goes to 0 of sine x over x, that's limit as x goes to 0 of sine x over x, these have to be exactly the same. And if we do that, we're sitting pretty. So let's take a look at another example, kind of like this one. Number 5. Okay? Now this one's slightly harder because I want this to be a 3x. This has to be a 3x. So what do I have to multiply the bottom by to get 3x? 3 halves. So I multiply the bottom by 3 halves. And if I multiply the bottom by 3 halves, we have to multiply the top by 3 halves. This was a little bit trickier one right here. Okay, is everybody okay? Very good. So what I'm going to do then, rewrite this, the limit, again it should be x. If I multiply the top, this just stays the sine of 3x. I want that to be 3x. But the bottom, if I multiply those twos cancel, what do I get? 3x. Remember, this is what you want. But the problem is we have something extra, and that came from the algebra. So we just multiply that to the front. 3 halves times that. And what do we get? 3 halves times, remember what this is all equal to? Just 1. So the answer is 3 halves. All right. One quick rule that always kind of gets people is number 6. What if we flip it? Well, if we flip it, we just flip our answer. Remember, if the limit as x goes to 0 of sine of x over x equals 1, then if I invert it, then the limit as x goes to 0 of x over sine of x is also going to be 1. And that is because 1 over 1, when I flip it, when I invert it, is also 1 over 1. So this is kind of like another rule for us. So we know that that's just going to be 1 right there. All right, let's take a look at number 7 here. Now number 7, we have a little bit trickier. It's tangent, but the same rule as for sine. This is a 2x. This needs to be a 2x. We have this negative, which we're going to factor out first. So I get negative the limit as x goes to 0 of the tangent of 2x over x. Remember, I want this to be a 2x on bottom right there. So multiply the bottom by 2, multiply the top by 2. And that becomes, bring that 2 out to the front, negative 2 times the limit as x goes to 0 of the tangent of 2x over 2x. And we can write our answer here. We get negative 2. Remember, all of this is just like sine. It's just 1. So our answer, negative 2. All right, so we're finished with part 1. And part 2, we're going to take a look at some more challenging limits, some fun ones for us. Okay, so make sure you go to part 2 and take a look at a few of these. We'll see you then. Bye.